Hello and welcome to Animated Education. Today we are going to continue talking about integrals. So here's the table of the most basic integrals. I don't think that there is a need to memorize this table if you already know derivatives really well, because finding an integral is a reverse of finding a derivative. However, it's up to you if you are going to memorize this table or not. Okay, so now I'm going to provide you with 10 examples of indefinite integrals, as well as 3 examples of definite integrals and 2 examples of how to calculate the area under the curve. For that, obviously, we will be using definite integrals. Okay, so let's go to first example. Let's say we have an integral of sine of x dx. Now this is equal, you can see it from this table, that it is equal to minus cosine of x plus a constant. Why we need this constant I explained in a previous video. So you can check yourself by finding a derivative of this thing. So I'll do it just once so you could see how it's done. So let's find the derivative of minus cosine of x plus c. This will give us now a derivative of, okay, let me write it consistently. So we need to find the derivative of cosine of x. We can put this minus before parentheses because, well, it's a constant. Multiply it to our function plus a derivative of c of a constant. So this will give us minus times, okay, let's do it like that, minus sine of x plus 0, and that is equal to sine of x, as you can see it here. Okay, an integral of 1 over x dx. Now this is equal to a natural log of an absolute value of x, okay, because a logarithm can't be less than 0 or equal to 0. So plus c. Now an integral of 3 to the power of x times a natural log of 3 dx. So this is a constant. This is a constant, so we can move before our integral, and this gives us natural log of 3 times integral of 3x, 3 to the power of x dx, and this gives us a natural log of 3 times 3 to the power of x divided by natural log of 3 plus a constant. These two will simplify, and we are left with 3 to the power of x plus c. An integral of e to the power of x dx. This is equal to e to the power of x, but don't forget a constant. Well, many students forget the constant, and, well, I do it myself pretty often, but don't forget it. Now, an integral of x to the power of 5 dx. This is equal to, I'll write it consistently, 5 plus 1 divided by 5 plus 1 plus c, and this gives us x to the power of 6 divided by 6 plus our constant. Now let's move to a bit more complicated integrals. So 1 over 3x plus 4. Now dx, okay, so now you can't simply write that this is a natural log, okay? So if you have a constant multiplied to an x and you can't simply take it before an integral, you need to write that it's 1 over 3, and now you can simply look at this as one variable, okay? So 1 over x would be natural log of x, so now it's natural log of 3x plus 4 and plus our constant. Don't forget that this is an absolute value. An integral of 4 divided by x cubed minus 3 divided by x to the power of 4 dx. Now we need to rewrite this x in denominator, and we can do it like that. Terrible sign of an integral. We can do it like that. 4 times x to the power of minus 3 minus 3 times x to the power of minus 4 dx. I did it because, well, you should know that a, the power of minus 1 is 1 over a. A is just some number. Okay, so we get that. Now we can integrate it. So we can integrate, okay, I'll write it again consistently. So we integrate 4 times x to the power of minus 3 dx minus an integral of 3 times x to the power of minus 4 dx. Now you can take these constants before our integrals, so you get that 4 integrals of x minus 3 x to the power of minus 3 dx minus 3 integrals of x to the power of minus 4 dx. Now it's pretty easy to calculate this, so we get 4 times x to the power of minus 2, because we added plus 1 here, divided by minus 2, minus 3 times x to the power of minus 3 divided by minus 3. Again, I added plus 1 here, so we get that this is minus 2 x to the power of minus 2 minus 3, excuse me, it's 1 because these simplify, minus x to the power of minus 3. Don't forget the minus here. Now we need to go back to how it looked. So it would be, and we get that this is plus 1 over x cubed. This is x. I forgot c, and I forgot in many places c. Here c, 2, c1 here, and I forgot it also here, plus c1 plus c2. I said that I forgot the c. Okay, let's move on. An integral of a square root of 5x minus 3 dx. Don't forget this dx also, it's important. So let's write this square root as a power of 1/2, so like this, and now we can integrate. We have a constant that we can't take out to our variable, so we write, let's do it at the color, so 1 over 5 times, now let's look at this as some variable with a power raised to the power of 1/2, so it would give us that this is 5x minus 3 the power of 3 divided by 2 divided by 3 over 2. So this will give us that this is 1 over 5 times 2 over 3 times 5x minus 3, the power of 3 over 2, and our answer is 2 over 15 times 5x minus 3, the power of 3 over 2, plus c, and plus c here, plus c here. I'm terribly annoyed. Okay, let's move on. Okay, so let's say we have an integral e to the power of 2x divided by e cubed dx. Now this is a constant, we can move it before our integral, so 1 over e cubed. Now integral of e to the power of 2x dx. We have a constant here that we can't take before our integral, so we write this is 1 over e cubed times 1 over 2 times e to the power of 2x, because an integral of 2 of e to the power of x is e to the power of x, and plus a constant. Okay, so this is equal to e to the power of 2x divided by 2e cubed plus c. Now an integral of sine of px plus 4 dx, this is equal. Now we can't take this p, this is a constant, anywhere, so we write that this is 1 over pi, excuse me, it's not p, it's pi, times minus cosine of px plus 4 plus a constant. So our answer looks like this: minus cosine px plus 4 divided by pi plus c. That's our answer. Okay, now let's calculate some definite integrals. So let's say we have an integral from minus 1 to 1 x cubed dx. Now we need to calculate this integral, so this will be x to the power of 4 divided by 4. We draw a vertical line here, write minus 1 and 1 as it was in the integral only. And now we put this at first, so we get that this is 1 the power of 4 divided by 4 minus, we always are subtracting, minus 1 the power of 4 divided by 4. Now I put this here, so we get that this is equal to 1 over 4 minus 1 over 4, and this is equal to 0. Now let's say we have an integral from 0 to pi cosine x dx. Now this will give us sine of x. We draw a vertical line from 0 to pi, so we put this at first, so sine of pi minus sine of 0, and this gives us 0 minus 0, and that is equal to 0, because this gives us 0 and this is also 0. Now let's say we have an integral from minus 3 to 1 of 2 dx. So now what this gives us is 2x. You have to know it, because once you take a derivative of it, it will be 2. So everything is correct. And we draw a vertical line. Also, as you can see, we are no longer putting a constant here, because this integral is definite, and we know the value of c here. We get it from putting the numbers. So from -3 to 1, and we get it at 2 times 1 minus 2 times -3. This will be -8. This will be 2. So that gives us 10. Now let's calculate an area under the curve of a function. So let's draw a coordinate system. So this is x-axis and this is y-axis. So let's say this is 1, this is 3. So let's say our function is f of x equal to -3 square. That gives us that the apex of a parabola is at 3 here. Okay, so now let's open these parentheses. So we will get that this is x squared minus 6x plus 9. So I now try to draw a parabola, but I'm not very interested in drawing it like an actual parabola to this graph, because the only thing that matters is that this apex is at 3. Now let's say we have two more functions, s is equal to 1 and x is equal to 3. So it looks like these are vertical lines. Okay, so now what we need to do, we need to calculate this area. We are asked to calculate this area. So how we can do this? Because, well, it might look a bit like a straight line, but it definitely isn't. It's a curve. Okay, so how to do that? Now we need to calculate a definite integral from 1 to 3 of a function. A function is this, x squared minus 6x plus 3 dx. So we are calculating an area under the curve of this graph from 1 here to 3 here, and this is that area. Okay, so we need to calculate this integral. So this is a 9 here. I made a little mistake. Now let's continue. So we need to calculate this integral. So this will give us x cubed divided by 3 minus 6x squared divided by 2 plus 9x, and we need to put our numbers here. So it's from 1 to 3, and once we do that, we get, this is actually an area. So we get that this is 3 cubed divided by 3 minus, this is actually just 3, okay, so because 6 divided by 2 is 3, so 3 times 3 squared plus 9 times 3, now minus, and all the same with 1, so 1/3 minus, this is 3, don't forgot, so 3 times 1 plus 9 times 1, and this is equal. So we need to find out what this is equal. So this will give us 9 minus 27 plus 27 minus 1/3 plus 9 minus 3, so it's 6, and this is equal, this 27 minus 27, so this left 9, this leaves 9 minus 6 and 1/3, and this is equal to 9, or maybe let me write it like that, 27 over 3, because, well, it's 9 minus 6 times 3 is 18, 18 plus 1 is 19 over 3, so this leaves us with 8/3. This is our answer. So this area here, we calculated this area is equal to 8/3, okay, some area units, okay. Now let's do one more example. So this is x-axis, this is y-axis, this is 0, this is 1, this is -1, this is minus pi of 2, this is pi of 2, this is pi, and this is minus pi. Now our function is minus cosine of x. So a graph looks like this. So when it's 0, when x is equal to 0, it's -1, so it's here. When it's minus pi of 2, when x is minus pi of 2, it's 1. It's 0, excuse me, so it looks like, and the same goes here because the graph is symmetrical, so it looks like this, and just like that. So we are not interested in this, okay? So we need to calculate an area from minus pi of 2 to pi of 2. So this is the area that we want, okay? So let's do that. So the area is an integral from minus p of 2 to pi of 2 of minus cosine of x dx. Now, what is very important here is that in our previous example, an area was on top of x-axis, okay? Now it's under the x-axis. So once we calculate this area, it will be negative. So we don't want that. Therefore, we need to write a minus here before our integral, okay? So now we can change our integral a bit, take this minus before our cosine x, and we get that this is simply minus pi of, from minus pi of 2 to pi of 2 cosine x dx. So we got rid of minuses. Now this graph is symmetrical, okay? From my drawing it might not very look like it, but it's symmetrical. So we can, and we calculating from minus pi of 2 to pi of 2. So we can put 2 here and calculate from 0 to pi of 2. It will be easier to calculate. So, and this is the same. Now, once we do that, it's not necessary, okay? You can do it with minus pi of 2, but it's just easier, and I think you should know it. But it's not necessary, it's your choice. So, our integral is equal to 2 times sine of x from 0 to pi of 2. Now, put this 2 before parentheses, and let's calculate sine of pi of 2 minus sine of 0, and this will give us this is equal to 1, this is equal to 0, so we get this is 1 minus 0, so it's 2. This area, this blue area here, is 2 units of area. Okay, so yeah, that's about it. I hope you understood. That ends my short course on mathematics. As I said in previous video, it became much longer than I expected, but it's a good thing. It means that you know a lot already. So yeah, I hope you understood, and see you next time.